Okay, let's just dive right into this. We're skipping the usual intros today because we need to get straight to a painfully common exam trap. I want to show you exactly how easy it is to literally throw away marks in your Cambridge IGCSE computer science exam if you aren't paying close attention.
Take a look at this question. Describe the role of transmission media in a computer network. Just 2 marks. Now, this is a classic Cambridge setup where the examiner is just silently waiting for you to fall into a very specific trap. It looks incredibly simple, right? Well, that false sense of security is exactly why so many students stumble right out of the gate.
And here's the trap in action. Take a look at this. It connects things together so they can talk. This devastatingly common 0-mark answer costs thousands of students their top grade. It's kind of heartbreaking, right? Because the student clearly knows what a cable does, but it scores absolutely 0 because it completely lacks specific syllabus terminology. The examiner isn't testing if you know what a wire is, they are testing your precise technical vocabulary.
Section 1. The examiner whisper and command words.
So, to fix this 0-mark trap, you absolutely must learn the examiner whisper. This means understanding exactly what the command words at the very start of the question demand from you. It's basically about learning to read the mind of the person marking your paper. This table right here is your elite strategy guide. If the command word is state, it just requires a concise fact. Give the detail and move on. Describe, like in our trap question, demands actual characteristics. You've got to paint a technical picture. Explain requires you to show the underlying mechanism, the why and the how. And finally, evaluate means you must apply your knowledge to a very specific scenario, weighing up the different factors.
Okay, so how do we guarantee those marks every single time? Well, you need to memorize this 4-step top-band answer framework. Step 1. State the core concept. Step 2. Provide evidence or data. Step 3. Apply scientific reasoning. And Step 4, which is honestly the most important, use precise examiner wording. Applying this exact sequence is how you consistently secure maximum marks, pulling yourself right out of the average and into that top band.
Now, in just a second, I'm going to show you the exact examiner clue that changes a networking answer completely. It's the kind of subtle hint that transforms an average response into top-tier perfection. But first, we need to build the foundational framework that makes that clue entirely obvious.
Section 2. Core network components defined.
All right, let's rapidly apply our new framework to the 3 core network components you absolutely must be able to define perfectly in Paper 1. First up, the server. A server is a powerful computer that holds shared files, programs, and the network operating system. Think of it as the ultimate provider for the network. It allocates shared data, printers, and software resources to anyone authorized to connect. Basically, without a server, your centralized network ecosystem completely lacks resource management.
Next up is the client. If the server is the provider, well, clients are basically the customers of your network ecosystem. A client is a computer that accesses and uses the network, relying entirely on the server to request and receive services. Clients aren't doing the heavy lifting here. They're simply consuming the resources that the server securely manages.
And our third core component is transmission media. These are the physical facilities used to interconnect computers in a network. Stuff like twisted pair wire, coaxial cable, and optical fiber. Transmission media are the actual physical channels, or links, that enable the transfer of data between those clients and servers. You can think of them as the physical highways of your network.
Now, when applying these components to specific architectures, like point-to-point networks, you've got to mention their unique advantages. For instance, they require absolutely no complex routing protocols. Plus, their direct link eliminates shared intermediate devices, which dramatically enhances network reliability. Furthermore, they support simultaneous bidirectional full duplex communication and ensure strict privacy, simply because the channel is totally dedicated.
Section 3. Advanced networks and security.
Let's escalate the stakes a bit, removing beyond basic setups into advanced networks and security, where the exam questions get significantly harder and require that scientific reasoning step from our framework. Look, because wireless signals propagate through the open air, they can be super easily intercepted by anyone nearby. This makes securing wireless communication a paramount concern to prevent data breaches. Therefore, robust encryption is absolutely required. Protocols like WPA2 or WPA3, that's Wi-Fi protected access, scramble the transmitted data, making it completely unreadable to unauthorized users without the specific encryption keys.
Now, when it comes to advanced throughput, comparing traditional transmission with physical layer network coding, or PNC, reveals a massive difference. Just look at this.
PNC achieves a staggering 100% throughput increase over traditional multi-hop network transmission. It literally doubles the efficiency by reducing the needed time slots for exchanging a packet from 4 down to just 2. It's a real game changer.
But here's the crucial point. You need to know how to critique it. If asked to evaluate PNC in an exam, you can't just praise the throughput. You must state the challenges. Dealing with severe MAC layer complexity, managing network layer flows, and handling simultaneous signal asynchrony and symbol misalignment from different nodes is what currently prevents PNC from widespread use. So it's incredibly powerful, but practically speaking, it's incredibly complex to synchronize in the real world.
Section 4, the Red Pen Interactive Clinic.
Okay, it's time for a viewer challenge. We're putting a flawed student answer right next to a perfect mark schemes safe upgrade. This is where we see if you've truly mastered the examiner whisper. The generic answer on the left, clients get files, media wires them up, WPA2 stops hackers, scores a devastating 0 marks. I mean, it feels somewhat correct conceptually, but it completely lacks formality. Now, look at the upgraded answer. Clients request services from servers via optical fiber transmission media, secured by WPA2 encryption scrambling. See the difference? This utilizes our 4-step framework to lock in every single mark. It's precise, technical, and entirely examiner approved.
Section 5. The Final Exam Challenge. So you now have the exact framework to dominate component definitions and network mechanics. But there is one final, truly lethal trap waiting for you in Paper 1 that catches out even the most prepared students. Before we uncover that, make sure to take a quick second to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, so you never miss an examiner's secret.
All right, here is that final provocative thought for you. You know how to perfectly answer an explain question now, but what happens when the examiner asks you to evaluate a network scenario specifically designed to trick you? To find out exactly how to dodge the most lethal traps hidden inside evaluation questions, click the next explainer on screen right now where we decode every single question type. I'll see you over there.